Here we are at example 3 from our 0.37 notes. We're asked to solve for the following variable. Here we're trying to find out what is W, and pretty much what we have to do is first identify what is our LCD, the least common denominator. For the sake of my students, I usually use the term the LCM for the denominator, just because the least common multiple, we start to think then of multiples of certain numbers. And usually it's a little bit easier for them to think about that. So, looking at our bottoms, 2, 1, 4, and 1. What is the smallest thing, or the smallest multiple that each one of these things go into? Well, 2 goes into 4, 1 goes into 4, 4 goes into 4 itself, and 1 also goes into 4. So the smallest thing that all of these items go into is going to be 4. So that's exactly what we're going to go ahead and multiply on both sides, because when we do that, all the fractions will go goodbye. And that's what we love. No more fractions. Multiplying this out, we notice that we have to distribute on the left side. So 4 times negative W. Really, that's the same thing as saying negative 1W. So ultimately, then we have 4 times negative 1W. Well, that's negative 4 W's. We keep the bottoms just as they are. 4 times positive 3 gives us 12 over 1 equals, on the right side we have 1W times 4 when we distribute the 4. That gives us 4 W's over the bottom 4. And then negative 5 times our 4 gives us negative 20 over 1. Again, we keep those bottoms. So this is what happens when we distribute. Now let's go ahead and simplify each one of our fractions. So negative 4 divided by 2 gives us negative 2 W's, plus 12 over 1 is just 12, equals 4 divided by 4, that just cancels out, gives us 1 W, and negative 20 over 1 just gives us negative 20. Now, again, there are various ways in which we can continue on this. Generally, I like to keep the variable positive. So here's a W and here's a W. And we notice that there's one on the left side and one on the right side. Now, in order to keep the variable positive, it makes more sense for us to add this 2W to both sides. Because when we do that, on the left side, this negative 2W is going to cancel with this positive 2W, leaving us the 12, equals, on the right side we have positive 1W plus another 2W. And we notice then that we end up with a positive 3W's. Okay? Again, what we do to one side, we have to do the other, and we did this. We added the 2W to make sure that our W is, the coefficient for W is positive. Minus 20. So the 12 and the negative 20 we haven't changed at all. Now, you could have subtracted this one over to the other side, but then you end up with negative W's, and that's just more room for human error. I mean, they're important to know how to work with negatives, and we'll totally do that this year. But for right now, just kind of get into the mindset of, hopefully if you can, keep your coefficients positive. Now, we want to still try and solve for W. Well, this negative 20 really has nothing to do with the W. So what we're going to go ahead and do is add that over. And once we add that to both sides, we have positive 12 plus 20. Well, that's 32 equals, on the right side, we still have our 3W, and our negative 20 cancels out with our positive 20. Now, lastly, we have 3 W's, but we don't want 3 W's. We want just W all by himself, like W equals something. So what we're going to do is get rid of this coefficient by simply dividing that coefficient. So in this case, 3 on both sides. On the right side, they just pretty much cancel out with one another, leaving us our variable, W, all by himself, equals 32 over 3. Now, there are some teachers that they want to make you have that into a proper fraction. Not me. There's way more math and stuff that you can do, in my opinion, with this improper fraction. So you are good right there. All right? 32 over 3 would be our final solution. Again, though, that is example 3 from our 0.3 set of notes.